Good morning students. Today we will learn how to design a multiplexer in indirect method. So this is indirect method of multiplexer designing. Now what is the utility of designing a multiplexer in indirect method? Actually it is used to half the size of the multiplexer. That means if a certain Boolean expression needs a 8:1 multiplexer to implement it, then by designing it in indirect method we can implement the same Boolean expression by a 4:1. Okay, so if a Boolean expression needs 8:1 multiplexer in direct method, then the same expression can be implemented by a 4:1 MUX in indirect method. So this is the utility of indirect method of multiplexer designing, to make the size of the MUX just half. Right? Now let us start. See, this is a Boolean expression. This is a 3 variable Boolean expression. A, B, C are the input variables. Now, if we implement this expression, a 3 variable expression, by using direct method of multiplexer designing, then what will be the size of the multiplexer? The number of inputs of the multiplexer will be 2 to the power of 3, because there are 3 input variables. And output of the multiplexer is always 1. So, size of the multiplexer is 8:1, right? So, this expression, this Boolean expression requires a 8:1 multiplexer to get implemented in direct method of multiplexer designing. Now, if we implement the same expression using indirect method, the size of the multiplexer is 4:1. So, just half. The size of the multiplexer is just halved in indirect method. Now, so how we can do this? So, let us start. If we implement any Boolean expression using multiplexer, what is the first step? The first step is to have the truth table, right? Now, what is the truth table for this particular Boolean expression? A, B, C are the inputs, 3 inputs. So, how many input combinations will be there? 2 to the power of 3, that is 8. And the output is Y. Suppose Y. So, what are the input combinations? Input combinations will be from 0, 0, 0 to 1, 1, 1. These are the 8 input combinations. Let us do, the first one is decimal 0, 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 input combinations. 0 means binary 0, 0, 0. 1 means binary 0, 0, 1. 2 means 0, 1, 0. 3 means 0, 1, 1. 4 means 1, 0, 0. 5 means 1, 0, 1. 6 means 1, 1, 0. 7 means 1, 1, 1. Sorry, 8 input combinations starting from 0 to 7, not 8. 0 to 7, 8 input combinations. So, 0, 0, 0 to 1, 1, 1. These are the 8 input combinations while we are using 3 input variables A, B and C. Right? Now, what is the output from this min-term expression? This is the summation of, so write, it is a min-term expression, so summation of small n, let us write it. Min-term expression means this expression when reduced in variable form, this will give you the sum of product form, right? Sum of SOP form. Now, what is the output according to this? The output is, for 0, the output should be 1, because 0 is mentioned in the min-term expression. The values which are mentioned in the min-term expression, for those input values, the output is 1. And for all rest input values, the output will be 0. This is how we must do the truth table, right? So, 0 is mentioned over here. So, for 0, 0, 0, the output is 1. 1 is mentioned. So, 0, 0, 1, the output is 1. 2, 0, 1, 0, the output is 1. Now, see, 0, 1, 1 is 3. 3 is not mentioned over there. So, output should be 0. 4 means 1, 0, 0. 4 is mentioned. So, output is 1. Then see, 5 is not mentioned in this expression. 6 is also not mentioned in this expression. So, for 5 and 6, the output should be 0, 0. Right? mentioned over here. So for 7 the output is 1. Right? For 7, input combination 7, the output is 1 for 1, 1, 1 input. So this is the truth table. Right? This is the truth table for this particular Boolean expression. So we have done with the first step of designing the truth table from the given Boolean expression. Right? Now the next is we need to do the designing of the multiplexer. Now while we are designing a multiplexer using indirect method, then additional step we have to do, that is the implementation table. Right? So after truth table, this is not, this implementation table, this is not required when we are designing the multiplexer in direct method. This is required only when we are designing the multiplexer in indirect method. Right? Then we require a implementation table. This is the second step of indirect method of multiplexer designing after this truth table. Right? So how to do the implementation table? Let us check that. Now see, we will design the implementation table in the second step of the designing from the truth table. Right? This is a mandatory step for designing indirect method of multiplexer. Right? For designing a multiplexer in indirect method, this is a mandatory part to have the implementation table from the truth table. This is the second step. Now see how to do this. See, in the indirect method, what should be the size of the multiplexer? The size of the multiplexer should be 4:1 instead of 8:1. So how many inputs will be there? 4 inputs, I0, I1, I2 and I3. So these are the 4 inputs, I0, I1, I2, I3. These are the 4 expected inputs in the multiplexer we are going to design. Right? Now, how the size of the multiplexer will be half? To do it, actually what we do, we use the select line, and the select line inputs will be the input variables. The select line inputs will be the inputs of the input variables. That is A, B, C, these 3 are the input variables. From these 3, we will use 2 inputs at select line, because in 4:1 multiplexer, what should be the select line? Select line is 2. Right? So 2 variables will be given in the select line input, and remaining 1 variable will be given in the input line inputs, like at the input lines, that is I0, I1, I2, I3. These are the input lines, and 1 variable will be given at the input line and other 2 variables will be given at the select line. Right? So let us do it. Let us see how to do it. See, there are 4 inputs, I0, I1, I2, I3, and I have chosen the MSB variable A for the input variable, that is the variable at the input line, and that is how I will design the implementation table. See, A means there will be 2 possible combinations of A bar and A bar and A. You just write down A bar A. Now, what are the outputs? 1, 1, 1, 0, 1, 0, 0, 1. Just write those outputs in row-wise manner, because the MSB is placed in rows. There are 2 rows. At one row, we have placed MSB A bar of the A variable, and at other row, we have placed A. Right? So, you need to put these outputs in row-wise manner. How? Just put 1, 1, 1, 0, 1, 1, 1, 0, then 1, 0, 0, 1, 1, 0, 0, 1. Okay. So we have put it. Now see, for I0 input lines, both the rows are 1. Both are 1. So for I0, we will connect logic 1 at input side. For I1, see, this is 1, this is 0. So 1 is corresponding to A bar. So I1 input line will be connected to A bar. Right? Now see I2. For I2, This is 1, this is 0, right? So which value is corresponding to 1? A bar. A bar represents 1. A represents 0 over there. So we will take 1. 1 is corresponding to A bar. So this line will be A bar. Now see I3. This is 1. So A. This 1 is representing A. So this input line value will be A. Right? Is it clear to you? Just see which value is 1. It is the 1 is representing A or A bar. If 1 represents A, then that input line will be represented by A. If 1 representing A bar, then that input line will be represented by A bar. And if both the lines are 1, then that input line will be represented by logic 1. Similarly, if both the lines are 0, in this example we are not finding that, but if in certain other example, if both the values are 0, both the line values are 0, then that input will be represented by logic 0. Okay. So this is how we will do the implementation table. Now after this implementation table, let us do the let us do the multiplexer. Let us design the multiplexer. K-map is not required over here. So for designing the multiplexer, what should be the size of the MUX? We know that the size of the MUX is 4:1, right? So there are 4 input lines, I0, I1, I2, I3. Now what I have said that for input line we will use 2 input variables. For select line. For select line we will use 2 input variables, and for input lines we will use another 1 input variable. Here we will use the input variable A at input lines and other 2 input variables B and C at select lines, right? See, I0 is logic 1. So connect logic 1. I1 is A bar. So A bar. When A is first or not get, then that will give you A bar. Right? Now I2 is also A bar. I3 is A. Right? So we have given the input variable A in input lines. So what are the rest 2 input variables B and C? We will give them at select line. Now in a 4:1 multiplexer, what should be the number of select line? Number of select line will be 2, right? Because the number of select line, if the number of select line is n, then the size of the multiplexer, that is number of input line, will be 2 to the power of n. In this case, there are 4 input lines. This is number of input lines. This is number of input lines. And this small n is number of select line. Now in this case, there are 4 input lines. So capital N is 4. So what should be number of select line? That should be small n, that is 2. Right? Now see, so there are 2 select lines, S1 and S0. We will give the input variable B at S1 and another input variable is C. That input variable we will give at S0. Right? So we have given 2 input variable at select line and another 1 input variable we have used it at input line. Right? There is obviously only one output. Every multiplexer is having a single output only. So Y is our output. Right? Now let us check. This is our designing. We have completed our designing. This is a 4:1 MUX. We have completed our designing. Now let us check whether this designing is correct. That is, we are getting the desired output. Now how to check whether we are getting the desired output? Because how to check it? Because if we have the desired output, then that will satisfy our truth table. Right? That will satisfy our truth table. Then only we can confirm that our designing is correct. Now let us check whether our truth table is satisfied or not. Right? So this is a truth table given. We have designed it from the implementation table and this is our truth table. right? So let us check whether this truth table is satisfied from this design. Okay. Now, what is the first input? 0, 0, 0. The first input combination is 0, 0, 0. Right? So, B0, C0. Okay? B, C, 0, 0. B, C are given at the select line and both are 0. So, when both the select lines are 0, which one input should be selected from number of inputs? For 0, 0 select line, I0 will be selected. Okay. So, Y should be equal to I0. And what is there at I0? See, logic 1. So, what is the output? Output is 1. Right? See, the output is 1 for 0, 0, 0 input. Right? Now, check the second combination. 0, 0, 1. BCR 0, 1. Right? So, B is 0, C is 1. So, for 0, 1 at the select line, which one input should be selected? I1. Right? So, I1 is selected. So, Y is equal to I1. Now, what is given at I1 input line? A bar. So, this is A bar. Now, what is A? A is 0. So, what is A bar? A bar is 1. So, for this 0, 0, 1 input combination, the output is 1. See, our output is 1. These two conditions are checked. Right? Now, go for the third input combination. This is 0, 1, 0. Right? Now, what is BC? 1, 0. So, B is 1 and C is 0. So, for 1, 0, which one input should be selected? For 1, 0, I2 should be selected. Right? So, Y is equal to I2. Now, what is I2? I2 is again connected with A bar from the implementation table. So, A bar. So, I2 equal to A bar. Now, what is your I? A bar. What is your A? A is 0. A is 0 for this combination. So, what is A bar? A bar is 1. So, A bar is 1. So, for 0, 1, 0 input combination, output is 1. We have got 1. So, output is 1. This input combination is also checked. Now, come for the fourth one. 0, 1, 1. So, BC is 1, 1. B is 1, C is also 1. For 1, 1 at select line, which one input should be selected? I3 should be selected, right? So, Y is equal to I3. Now, what is given at I3? A. So, Y is equal to A, right? Now, see, for 0, 1, 1, for this input combination we are checking, right? So, what is A? A is 0. So, what should be the output? The output is 0. Got it? So, see, for 0, 1, 1, the output is 0. So, for 0, 1, 1, output is 0. This is checked. Okay. Now, come to the next input combination 1, 0, 0. Right. See, again BC are 0, 0. Okay. B0, C0. So, as BC are 0, 0, which one input should be selected? I0. Okay. So, output is I0. Now, what is connected to I0? 1. Logic 1. So, the output is 1. Okay. Output is 1. So, see, for 1, 0, 0, we have got output 1 and here also the output is 1. So, it is checked. Right. Now, come to the next combination, that is 1, 0, 1. So, B is 0, C is 1. For 0, 1, which one input will be selected? I1. What is I1? I1 is selected. What is I1? I1 is A bar. Right? I1 is A bar. Now, what is A over there? See, A is 1. So what is A bar? A bar will be complement of A. So 0 because A is 1. So A bar will be 0. So output is 0. Right? See, the output is 0. So this is checked. Now the next combination is 1, 1, 0. So B is 1, C is 0. B is 1, C is 0. So for 1, 0 at select line, which one input is selected? I2. What is I2? What is I2? I2 is again A bar. A bar. Now what is A? A is 1. So what should be A bar? A bar should be 0. A is 1. So A bar is complement of A, that is 0. See, we are getting output 0. Here also in the truth table the output is 0. So checked. Now the next one, 1, 1, 1. Right? So your B is 1, C is 1. B, C both are 1. So which one is selected from the input lines? A, because for 1, 1 I3 is selected. So A, output is A. I3 is equal to A. Now what is A? A is 1. So output is 1. Right? See, from the truth table also output is 1. Right? So we have checked all the outputs according to our inputs. So our truth table, the whole truth table is verified. So our designing as the truth table is verified, we can tell that our designing is correct. So this is how we have made the size of the multiplexer just half by using indirect method of multiplexer designing. In the next class, we will cover the expansion of multiplexer. That is, what is the expansion of multiplexer? The expansion means we will use, suppose 2:1 multiplexer to have a 4:1 multiplexer, or 4:1 multiplexer to have a 8:1 multiplexer. This is called the expansion of multiplexer. Okay. So in the next class we will do that. Till then, bye bye. And if you yet not subscribed the channel, please subscribe the channel to have all the videos. Thank you.